Intel's NUC line has some of the coolest names and some of the coolest designs. Over the years, we've worked on the Ghost Canyon NUC and the Hades Canyon NUC. We later turned it into Hades River, as we called it, because we water-cooled it with this really unique assembly from a case modder. And the NUC line is one of the things that Intel does extremely well. The mechanical design is sometimes brilliant, or at worst, just very interesting. And in the case of this one, which we still need to work on the names, Intel, this is the NUC11PHKi7C. It's an i7 CPU with a 2060 soldered to the board. It's all BGA, but very compact assembly. And it is pre-built that would be deployable to the back of a monitor in a business environment, or just if you need something that's maybe a portable editing rig, which is what I'm looking for right now. Before that, this video is brought to you by Squarespace. Squarespace is what we've been using for years to manage our own Gamers Nexus store, and we've been incredibly happy with the choice. Squarespace makes e-commerce easy for those interested in starting stores, but it also has powerful tools to build all types of websites. Photo galleries for photographers, resume and portfolio sites, and small business sites are all easily done through Squarespace. Having built a lot of client websites the old way before running GN full-time, we can easily recommend Squarespace as a powerful, fast solution. Go to squarespace.com/gamersnexus to get 10% off your first purchase with Squarespace. NUCs are extremely small form factor Intel PCs with normally soldered BGA CPUs and VESA mounts that can be used in situations where fully functional tiny PCs might come in handy, like an HTPC for consumers. Tiger Lake, for example, has hardware accelerated AV1 decode, or a kiosk computer for a business. The VESA mount means that a NUC can be attached to the back of a monitor for extra space savings. NUCs are generally sold as full units, so there's NUC mini PCs and then there's NUC kits. This is a kit. That means we've provided our own RAM. We're using a HyperX Impact kit, and it also means we've provided our own SSD. We're using a Team SSD, although there's a caveat there. We had to remove the heatsink from it. Ghost Canyon was really cool because it was completely different. Very powerful box. It had a socketable GPU, so a DGPU could be used in it, and the card itself was socketable. So you could buy just the compute unit, or whatever they called it, which was a PCIe card that you could install more or less anywhere. And you could technically socket it into a motherboard if you wanted, and use it as a computer within a computer. So that was a genuinely unique product from Intel. And this line, where Intel is lacking in CPUs, is sort of a reminder that Intel is a huge company, and it has engineers in different departments, some of whom are actively working on things that perform and are received very well, and others working on Rocket Lake. Let's move on though. So the NUC compute element is the one we covered last year. There's NUC laptop kits as well. The Phantom Canyon one that we have in today is more conventional style. It's more similar to Hades Canyon. It uses the same form factor as Hades Canyon, which we tore down in 2018, but it contains a 4-core, 8-thread Tiger Lake i7-1165G7 CPU, which you can see in our teardown shots of the PCB from Phantom Canyon, as well as a BGA NVIDIA RTX 2060 with the memory soldered to the board, rather than Hades Canyon's unique on-package Vega M graphics where AMD and Intel work together, or Ghost Canyon's optional add-in card. So this version of it is $1,200. You would then buy your own SSD and you would buy your own RAM. But a 2060 and a 4-core 8-thread part for $1,200 is obviously far more than you would pay for those things in normal market conditions for a pre-built system, but it's tiny and it's pre-built, and that's kind of the point of these. It does have some unique features, nothing that's worth hundreds of dollars, but the exterior of the chassis has a light-up logo of the Intel Skull logo that can be blackened fairly easily, and we'll show all of that in the teardown. We've got a couple notes on problems we had with storage, some benchmarks, other stuff to go over, but let's start with a disassembly of the new Intel NUC. Time to take the Intel NUC apart. We're gonna be doing this on our brand new large ModMat Volt. You can find this on store.gamersnexus.net. They're sold out, but we have them on back order. So if you want to guarantee you get one on the next run, go to the store and place a back order. So the bottom is something you'll install when you get it, if you get one. It's just 2 large Phillips size 1 or 2 screws. Okay, so the outer chassis shell is 2, 4, 6, 8 screws. That comes off. You've got a plate here that is fairly opaque, really. It's actually kind of impressive. So it's not 100% opaque, but if we take it away from the light, I'm gonna pull it down now. I mean, that's fairly black. Like, they did a good job on that. And that's why you can't see the skull through it unless the skull is illuminated. So good work by Intel for giving the option to black out the lights if you don't want all the RGB. So the next thing that's going to come out, they do actually have arrows marking some of these because there's a few user serviceable parts. Actually, let's show this. So you'll see up here as an example, there's a number 4. They've got a number 3 down here. There's number 1 right there. There's a 5. These two don't have order numbers. There's a number 2. There's probably a couple others somewhere I missed. But this is all what comes out to get to the user serviceable part. So that would be the memory and the SSD. We're going to take out the badge plate first. I'm just going to track these internal screws in a separate grid location on our mat. So let's see. The question I always have is whether it's attached to a ribbon cable, and it is. So we're going to take out the rest of this now. I'm going to go backwards though. We're going to start with 3. Oh. Okay, so this whole thing comes up, including that ribbon cable I was worried about. We're going to disconnect that cable. That's going to be for the power for the LED. Underside, there are 2 thermal pads that really don't make great contact, but technically contact the SSDs. We've only got 1 in here right now. And this is as far as we've taken it. So now what I'm going to do is take the motherboard, which is effectively the whole computer, out from the chassis, and we'll look at the cooling solution. So the numbering sort of continues. This is marked number 7. That is a different screw than the others. Okay, so backside of this, I think my next step is going to be to pry apart the shell. We're going to check, but that looks like probably the location of the GPU. That's probably the location of the CPU, and they're most likely going to share a cooler. And then we've got a CMOS battery. This is actually good. I do like this. The CMOS battery is user accessible. It is not difficult to get to that battery. And that's a small but nice feature because it means it's relatively easy to reset things if you need to, or if you use this thing for a decade and the battery dies, you'd be able to get access to it. And that's good because these things end up in secondhand markets eventually. There's a good chance that it's usable for a decade. And if the only thing that dies is CMOS, then making it easily replaceable is a good thing. Okay, found the next step. So on the front of the chassis, there's 2 disguised screws that blended in past me because they are within the venting. I think it's probably going to push through. That's kind of neat. Let me just disconnect this cable. So it looks like, wow, that's pretty cool. One more cable over here I missed. It's an LED. Well, yeah, Intel honestly does a really good job on these NUCs. This is good engineering. It sockets together. It's easy to assemble on a factory floor. It's easy to take apart for the end user. These are all good boxes to tick, and it's relatively small. Now, there are a couple shortcomings we're going to get to, mostly related to ventilation. So the GN 5mm hex will fit that. Not bad. Okay, that's fairly easy to take apart. Okay, let's take a look at this cooling solution. That's the important part here. It's actually not a ton of surface area, and that's because all of this area that could be used is instead being used by 2 fans. So there's 2 blower fans here. They're both Delta fans. So this fits together like that, where you can see these fans have their duct butt up against the fin stack that looks like a copper heat pipe with aluminum fin stack set up. Okay, so here's how it all works. What we have is 2 fans in here. They'll pull air in through the bottom, which does mean when it's flat like this, it's not as exposed to air, but the air is coming in through the bottom. You've got about maybe 5 millimeters of elevation from these rubber feet. And once the air is pulled in through the bottom, the other side of this hole, it will be pushed through the duct here. That goes through the fin stack. It's very simple. There's not a whole lot of other places for the air to go because it's all guided straight into the back of this, and then it spits out the other side. As for the side ventilation, you will want to get a little bit of air movement in there, even if it's not active. But you can see there's not a whole lot of holes punched in the side, and those then would have to line up with with these anyway. So it's fairly restrictive on the sides, but the part that matters is the back exhaust, which would line up with this, and that is mostly open. So that's good. There's not a lot of plastic in this ventilation. That's something we always look for. There's not a lot of plastic in the shell either. So that's all good looking. The other side of this is mostly blocked off. There's not a lot of perforations. Again, not as big a deal since the air is not coming from there, it's coming from the bottom. So this is the part where it matters. The sort of, we'll call it hole to steel ratio or hole to metal ratio is not great here. For rigidity purposes, most likely, they have a fairly thick metal between each of the holes in the grill, and that's probably to just keep it from getting compressed by the user too much and causing damage or indenting, but it does mean that it restricts the intake a bit. For this thing, let's take this apart the rest of the way. So Intel's got a couple small details here. This is mostly standard laptop cooling design, but it's executed in a different way because of the shape of everything. So the CPU and GPU are not too far apart from each other. So they're about 10 centimeters apart, edge to edge, and maybe like 7 or 8 center to center. But there's some small standoffs here, pins, to give some extra surface area. Not a whole lot, you can't get much out of that, but small attention to detail thing and good use of extra surface. This is actually good too. They've taken a page from the Microsoft book and they've numbered the screws. 1, 2, 3, 4. This one's not numbered. And then 5, 6, 7, 8. So that's more or less exactly how I would have done it. I'm gonna get this out of here early though. Oh, well, that was straightforward. Okay, so in terms of the rest of the solution, here's the PCB. We have 2 pieces of silicon over here. One of those is going to be chipset, and then GPU. Let's clean these off before we go further. Okay, so there's the NVIDIA die. It's actually labeled N18EG1BKDA1, different labeling than the desktop parts. So the memory is contacting here. You can see the indents. So that is in contact with part of the heatsink, which bridges to the copper cold plate via what looks like probably just welding like usual for these. And the copper cold plate is connected to the 3 copper heat pipes, which you can see here spread over the surface of the fin stack. The heat pipes contact the fin stack for, let's see, we've got 2 additional memory module locations that are not being utilized over on that side. Now these might change based on which memory controllers are disabled on the GPU die, because you can see that there's 3 more memory modules over here. So we've got a total of 6. This there is potentially, I haven't checked, there might be another SKU that would allow for another 2 modules to be connected. In all cases of the memory, they contact the main part of the heatsink. And then on the other side, it's just 2 heat pipes contacting the chipset and the CPU. Pretty straightforward, also via copper cold plate. And then we've also got the other VRM components connecting to thermal pads scattered throughout. So inductors up here, and then MOSFETs here, aligning with where they are on the board. That pretty much covers it. Before we get into the games and all the other testing, we ran our usual test for CPU, thermals, and frequency. We rendered the custom GN logo Blender scene on the CPU for 20 minutes and tested it in the vertical orientation first. After the file finished loading and rendering began, all cores held a 4.1 gigahertz frequency for 20 seconds. During this period, the maximum core temperature peaked at 80 degrees Celsius, and average core temperature was approximately 73 degrees, with a somewhat wide core-to-core delta on this chip. It's clear why there's a boosting window on this device. If we forced the CPU to hold 4100 megahertz for much longer than this, it'd be blasting the fans while baking itself. After the boost window though, the CPU locked down to its 30 watt PL1 limit and maintained core clocks between 3400 and 3500 megahertz for the rest of the test, skewing more towards 3.4 by the end, and average core temperature reached steady state at about 61 degrees Celsius. The cooling fans are more than capable of maintaining this performance at our room ambient temperature of 21 to 23 degrees, but that power limit drop is necessary. we used the default balanced cooling profile for all testing, which turns the relevant fan off entirely when below a CPU temperature of 50 degrees and below a GPU temperature of 42 degrees. When active, the minimum duty cycle is 30% for the CPU fan and 35% for the GPU fan. Functionally inaudible at this point, and both fans increment speed by 1% per 1 degree Celsius increase over the minimum temperature. This means that there's room to set a more aggressive profile manually. All of these numbers are adjustable per fan and BIOS with much finer control than would be seen on something like a typical laptop. During a full system torture test in vertical orientation, GPU temperature stabilized at 68 degrees Celsius and average CPU core temperature stabilized at 74 degrees Celsius. This is significantly warmer than the 61 degrees steady state CPU temperature logged with just Blender running, so it's clear that the temperature of each component affects the others in this small package. Given the cooling solution we looked at earlier, this all makes sense. It's too small of a space for the components to not influence each other thermally, and they're sharing the same heatsink at the end of the day. The M.2 slot ran around 60 degrees Celsius for most of this test, with the internal temperature sensor running around the same, establishing nearly a 35 to 40 degree delta between internal and external case ambient temperature. Tested in vertical versus horizontal orientation, and with a controlled fan speed of 60% here, there's only a few degree difference. It's a couple degrees when under 100% load for both the CPU and the GPU, and part of that is because we set a higher RPM of 60% and thus higher pressure, which allowed the static pressure to overpower some of the limited intake access. At 60%, it still wasn't loud enough to be annoying, especially if you're using it for an HTPC across the room. So in this situation, with the higher pressure and higher RPM, the horizontal orientation isn't as bad as it would look like. At the lower RPM settings, though, you'll have a little bit more difficulty overcoming the small gap between the bottom of the chassis and the actual intake. Wall power is the most relevant power metric for this NUC since it's sold as a unit and the majority of the components are soldered to the board. So what you get at the wall is what the whole thing's going to take. There's no point in getting CPU or GPU only, and to get those we would have to solder things onto the SMDs anyway. The CPU-only Blender workload took 82 watts during the 20-second boosted window, and then it dropped to 58 for the remainder of the test. And as a reminder, again, that's the full system, so that's really not too bad. Tests that utilized the GPU caused much higher power draw, checked at 160 watts during a GPU-bound 4K benchmark of Rainbow Six Siege, and 176 watts in an attempt to create a CPU bind with F1 2020 at 720p. But the F1 test resulted in high usage of both the CPU and the GPU, hence the power draw being higher than Rainbow Six Siege, where the CPU did relatively little work while the GPU was choked. Full system torture workloads resulted in a maximum observed short-term power draw of 222 watts. The less abusive Blender and FurMark torture workloads peaked at 199 watts and had dropped to 168 when checked 5 minutes later. The power envelope is relatively low for the work being produced out of this small box, and this is looking a lot better than some of Intel's desktop parts right now. For performance testing, we chose to run our existing CPU game test suite. These results are not directly comparable, however, to any other CPU test because the hardware is entirely different by nature of being a pre-built box. These tests have been tuned for CPU bottlenecking, meaning that they're intentionally less taxing on a GPU normally. But normally we're using a 3080 for CPU reviews. This is a much lower end device. The NUC is absolutely capable of running this suite of games at 1080p with medium to high settings. And the GPU's RT cores mean that DLSS can be leveraged to enable even higher resolutions in titles that support it. Especially impressive on the list is Red Dead Redemption 2 at 77 FPS average, with our usual medium settings profile applied here. This is arguably the flashiest game in our CPU suite that we applied to the NUC, and the NUC enables a playable frame rate at the most common gaming resolution without dropping the settings all the way down to the bottom. Rainbow Six Siege has the highest average FPS at 207 with excellent 1% and 0.1% lows. And this is good news for FPSs that require fast reaction time. There's plenty of room to scale to higher resolutions in some of these games, like Rainbow Six, for example. And the 2060, again, being an NVIDIA GPU, gives certain advantages, like DLSS. Overall, these results show that the NUC is useful as a mid-range gaming PC equivalent, although the lack of upgradability with soldered CPU and GPU BGA chips means that it might not age as well as a desktop or a compute element. Out of curiosity, we ran many of the same games from the CPU suite with the RTX 2060 disabled and the integrated Iris Xe graphics enabled as the primary GPU. The horizontal axis of this chart has shrunken down now to 60 FPS, so keep that in mind. It does skew comparing to the previous one. The IGP is just nowhere near as powerful as a discrete GPU, hence the scaling, and none of these results are what we would consider to be particularly playable in their respective games. It's more powerful than an 11600K's UHD750 integrated graphics that we tested recently, but we'll cover that in more detail later on. The takeaway here is that despite the move to 10 nanometers and relatively impressive specs when compared to the previous generations of IGPs, the integrated GPU on the 1165G7 isn't the best choice for gaming, especially when there's a 2060 soldered to the same board. We next ran the same suite of IGP tests that we had previously run on the i5-11600K's UHD750 IGP. The UHD750 is on Rocket Lake and hosts 32 EUs, whereas the 1165G7's Iris Xe GPU is on newer silicon with 96 EUs. CSGO and Rocket League averaged about 60 FPS on the 750. Frame rate averages were 35% better here at 81 FPS for CSGO and 25% better for Rocket League. The same frame pacing issues that we saw in these two titles on the other IGP were still present, but marginally more tolerable with the increase in average frame rate. Fortnite was completely playable here, albeit at the lowest settings, while Minecraft scored as high as ever thanks to the extremely restrictive 16 chunk render distance cap that's automatically applied. You can probably hack your way around this, but for sake of testing, we didn't do that. The Chromium build benchmark is more comparable to previous results than the game benchmarks were, since it's exclusively a CPU workload, so we can have them all on the same chart. We haven't revisited any of the 4-core 8-thread CPUs for this round of benchmarks, so the 1165G7 lands firmly at the bottom of the chart at 246 minutes total required to complete the code compile. The next worst result on the chart, the 6-core 12-thread i5-11400, finished in 36% less time than the Intel NUC did. We rarely test mobile CPUs, so it's been a long time since we've seen a 4-core i7, and the low core count really hurts in heavily multi-threaded workloads like this one. Blender testing showed similar results, but we've already made our point. That's not what the CPU is for. It can kind of do it if you're in a pinch, but otherwise you should use basically anything else. We'd like to be able to use a NUC for mobile editing, which makes the Premiere test one of the most important to us. The NUC's performance was initially abysmal, but we ran a second pass with playback acceleration specifically handed off to the Intel IGP, which boosted Puget's extended live playback score subcategory up 109% from 36.8 points to 76.9 points. And it boosted the standard live playback score up 49% from 42.7 to 63.6 points. Other subcategories weren't strongly affected since the 2060 was still used for encoding and the CPU was unchanged, but playback performance was visibly improved. The overall results are still at the bottom of the chart since the other tests were performed using an RTX 3080 for GPU acceleration, but this is still one of the most compelling use cases for an IGP in a system that still contains a discrete GPU. Keep in mind that the rest of these CPUs are paired with a 3080, but not all tasks in Premiere are benefited from a higher-end GPU like that. Clearly, it was a detriment compared to the IGP in this specific instance with the 2060. Now, a couple final notes as we're closing out. For storage, we used a Team Group T-Force Cardea C440 PCIe Gen 4 SSD. Two of the main marketing points of this SSD would be the ceramic heatsink and the fact that it's PCIe Gen 4, both of which are wasted on the NUC. The 1165G7's CPU PCIe lanes are 4.0, but the M.2 slots are both listed as PCIe Gen 3 in the specs. And the Intel Optane H10 512GB or plus 32GB drive that ships with the pre-built NUC, which is not the one we reviewed, is also limited to Gen 3, as is obviously the RTX 2060. As for the ceramic heatsink, the NUC has built-in thermal pads designed to sink heat from M.2 drives into the chassis. That's a good design. It's making use of the material that Intel has. But it's important to remove the pre-installed heatsinks from M.2 drives before installing the drive into the system. There are two M.2 slots internally. There's a wireless card soldered directly to the board rather than getting its own distinct M.2 slot as in the Hades Canyon NUC. But one of the big problems that we discovered with this wireless card that's soldered onto the board is that it's not replaceable and it's not really repairable. right to repair issues aside, the real problem with this one is just so there's the two antenna that connect to a wireless card. It's normally black and white. They're not always marked that way, but these are marked G1 and G4. And for these two connectors, there's a female snap on the wireless card, and then there's a male stud, it's called, on the actual wireless antenna that connects to the snap. It is so fragile and small with these connectors, and it's soldered to the board, so there's not a lot of movement you can do, you can't replace it, that when we removed the G4 marked connector, the female snap disconnected with the stud on the antenna, still socketed together. There's no way to fix that. It's not like a fix thing. It's you tape it back into place and you hope that the connection's good enough, which is what we ended up doing. Now, if this were an M.2 card, it'd be simple to just pull the card and put a new one in. But also I've never had that happen ever before when working on a wireless device. So they're really fragile on this thing, and there's nothing special to it. You kind of twist and pull off, and that's all there is to it to get the antenna off of the M.2 snaps, or the studs. But in this case, the studs come off with the snaps still secured to them off of the board. So that is a problem, and it'd be nice if it were back to the original socketed card. We know that this is technically a little bit smaller, but it's not that much smaller. It's not worth it. Now, this thing is not really meant to be user serviceable past that level. So it goes down to the RAM and the SSD and the wireless card that you can't fix. But beyond that, there's no renderings in Intel's 3D models that they have, which is actually kind of cool that they have those up. No renderings beyond that, and you're not meant to take it apart further. It's not hard, though. Now, for graphics, there are a few problems where the IGP, powerful as it actually is, doesn't really get used anywhere if you plug in with anything except for Thunderbolt. So there's a Thunderbolt port on the NUC. These are connected to the CPU, while HDMI and mini display port is connected to the GPU. Connecting via Thunderbolt still prioritizes the 2016 games by default, but it also allows the 2060 to be disabled completely, which is how we performed our IGP testing. Other than the basic hardware, though, the most useful part of this is that connecting via Thunderbolt means that without any effort, things like Premiere will leverage the IGP in a way that's actually beneficial. So you might want to connect through that method, although our monitors don't really use those connections. We would ideally adapt it. So beyond all this, the only out-of-place item is the far-field quad array microphones that are embedded in the NUC. You can disconnect them easily, so we did check that. If you're paranoid, it is something you can disconnect if you don't want microphones in there. They're visible as 4 pinholes in the case, and you can unplug a single cable from the motherboard from it. So that's it then. Overall, it's convenient, it's very portable. One of the downsides to these, so you may have seen some of my GN Steve channel videos in the past where I'll go do some downhill mountain biking. That involves traveling and driving. These have always appealed to me personally for that reason. For our team, for GN, it's appealed to us because it's potentially a portable editing rig for when we go to Taiwan or Las Vegas or whatever for trade shows. Now, the problem we always run into with that is, as nice of an idea as this is, and this is in some ways easier to work with than a laptop, especially through input, you're still trusting that you can plug into a TV on the other side if your hotel has one that hopefully you can just go via HDMI to, or you're carrying that stuff with you. So it's not quite as portable as it looks once you factor in bringing the peripherals with you. Now, if you have a place to work at home, you have a place to work at work or whatever, or you're going between houses, then something like this isn't bad if you have everything all set up in the places you're going to, and all you have to do is plug it all in, functionally dock it. It's basically a laptop at that point, but a little bit smaller and relatively powerful. Not more powerful than the high-end laptops, but certainly smaller than that. For $1,200, it's expensive. It's not abnormal for the NUC line. This is more or less the pricing you would expect, and given the market right now, it's not that crazy. So anyway, pretty good build quality. A couple problems with it, but we've gone over all those. And that's it for the Intel NUC for Phantom Canyon this time. Keep up the good names for those, Intel, but let's move away from NUC11PHKi7C, please. Still haven't memorized it, and I've been working on this thing for like a week or two. So that's it for this one. Thanks for watching. Subscribe for more. As always, you can go to store.gamersnexus.net if you'd like to grab one of our mod mats or mouse mats, or you can go to patreon.com/gamersnexus for behind the scenes videos and bonus videos, and we'll see you all next time.